Good everyone, I am Adeboale Daniel. You guys, you are welcome to eTUTOR YouTube channel. Now for today's class, I'll be taking economics, and the topic I'll be looking at is titled production function. I welcome you all once again, and I would also like you guys to subscribe to our YouTube channel. Thank you. So for today's economics class, we want to look into the topic titled production function. Now there is a big difference and a clear difference between the topic production and production function. In fact, production as a topic in economics is wide, yes, very, very wide, because production is one of the essential microeconomics topic, yes, because in microeconomics, we focus on 4 major variables: production, profit maximization, price determination, and consumer theory. So for today's class, we want to look at production function. But before I start, let us quickly look at the meaning of production. What is production? Production simply means the creation of utility. The creation of utility. How do I mean? There is a saying that says production is not complete until goods and services, final goods and services, get to the consumers. But production is not complete if consumers cannot gain satisfaction from the commodity that has been consumed. So production is only complete when utility has been gained or derived by the consumer from the consumption of a manufacturer's product. So that's why I say production is the creation of utility. You are creating satisfaction. Now, as a producer, the primary aim is to maximize profit. Yes. Now, let us look at a producer in this view. You see, one thing about production is that there must be what you call efficiency. Efficiency. Now, what do I mean by efficiency in production? Efficiency in production talks about 2 things. The first one, we call it economic efficiency. Economic efficiency of production. While the second one talks about the technological efficiency of production. Now, you see, the economic efficiency and the technological efficiency are the 2 primary aims of every producer. This means, for economic efficiency, it simply means when a producer maximizes the highest profits and minimize cost. It simply means when a producer is able to make the highest possible profit at the lowest possible cost. We call such production efficiency economic efficiency. But technological efficiency simply means when a producer is able to achieve the highest production or output of goods and services with the limited available resources, we call it technological efficiency. That's the technical know-how of production. You want to make sure that your output is at the highest, maximum. And when your output is at maximum, we say the marginal revenue equals the marginal cost. At this point, there is equilibrium. So you try to make sure that there is highest production with the use of your limited available resources. So that talks about or explains the concept of technological efficiency. Now, in production, we want to deal with majorly our factors of production, because what brings about production is without the factors, production cannot take place. And it is from production, when you produce, it is from production we get the theory of cost, because to produce, you need to spend money. So the money spent to acquire your production factors is the cost of production. And when you have incurred your cost, you try to determine the amount of money you realize, because as a producer, why do you produce? To commercialize your product. So you earn what you call revenue, which is the income from output. And your primary aim is now to say, okay, when you compare your revenue and your cost, you try to achieve what? Profit. And this profit differs. So you try to achieve what? Highest profit. Highest profit. That is your aim. So coming back to production as the topic, We look at production itself, meaning and types of production, the stages of production, primary, secondary, and the tertiary stage. We look at the scale of production. What do I mean by scale of production? That is the small scale, the medium scale, and the large scale. So under the large scale, we have the economies of large scale and the diseconomies of large scale. These two are divided into internal and external. That is another aspect of production. We also have another aspect of production. We call it production possibility curve, which explains the relationship between the PPC and opportunity cost. That is another aspect of production. Then we now have production function. Production function. Now, production function is a mathematical equation or an expression that shows the technical relationship between production outputs and production inputs. It shows the relationship between output and what? Input. Now, what do I mean by output and input? From the word function. If I say y is a function of x, it simply means the value of y is dependent on the value of what? X. Of which x and y, they are called variables. X is an independent variable, y is a dependent what? Variable. So same thing. If we want to relate it to our production, we represent y as Q, which is the output. So output, which is the quantity Q, is a function of two variables. What are the two variables? The first variable is capital, while the second variable is what? Labor. So production or output is a function of what? Capital and what? Labor. So under production function, we minimize the factors of production to two variables, labor and what? Capital. Normally, when we want to highlight the production factors, we say land, labor, capital, and entrepreneurship. But you see, land as a factor of production has been minimized to what? Capital. What type of capital is land? It is a fixed and a durable capital. Entrepreneur has been minimized to labor. And you know, in our production function, we are also going to be dealing with graphs. So that is why we can only what? Minimize it to just two variables, capital and what? Labor. Now, we have different production functions. We have the linear production function, we have the Leontief production function, but there is one that I want to use as a case study for this topic. We call that production function Cobb-Douglas function. Now, you see, this Cobb-Douglas production function, it was introduced by two economists. Yes, two economists. The Cobb-Douglas function was introduced by a man named Charles Cobb and another man named Paul Douglas. So Charles Cobb and Paul Douglas, they joined their brain together and bring out a function which is called the Cobb-Douglas function. So the Cobb-Douglas function is expressed as Q equals function of K and L, which now furtherly extend as Q equals AK alpha L beta. Q equals AK alpha L beta. So where our Q represent our output or our unit of output, our A represent our technical progress, because capital in terms of technology, technical progress of capital, which is the effective capital. So technical progress. Our K in production, K represents capital. We use K to represent capital. Then our L represents labor. So capital and labor. Now you see this alpha and beta, they are Greek sign. So alpha talks about the proportion of our capital So like I said earlier, production function shows the technical relation between the inputs and outputs. Now remember that for these inputs, money was spent to acquire them. And these inputs, they are called the factors of production. and for this output, the money spent to acquire input is what resulted to output, which is what you have been able to produce, your finished goods and what? Services. Now, there's a curve that represents input. There's another one that represents output. There's what we call the concept of isoquant first, isoquant and isocost. We have the concept of isoquant and isocost. Now, you see, isoquant and isocost, they are two opposite variables in production function. We use this to explain this. We use this to explain this. So they have their own respective graphs. The word iso means equal. Equal. So equal. Quant simply means quantity. Quantity. Cost. So isoquant simply means equal quantity. Isocost means equal cost. What do you mean by isoquant? Now, an isoquant is a curve that produces the same amount of output at a given level of labor and capital employed. So, irrespective of the unit of labor or unit of capital you are employing in your production, you are going to produce the same unit of output. So, if you produce 30 units and you want to employ more labor, that means you need to sacrifice more units of capital. So, irrespective of labor and capital employed, you are still going to produce 30 units. Now, let us look at the isoquant curve itself. Now, one thing is you should note as an economics student is that an isoquant is always convex to its point of origin and it is negatively sloped. This is the slope of the isoquant. This is the slope of the isoquant. So this is an isoquant. This is an isoquant. And this isoquant, it has properties. The properties of an isoquant curve is synonymous to the properties of an indifference curve. Yes, because that is why, remember I told you that production is the creation of utility, and utility falls under theory of consumer behavior. So in production, we have isoquant. In theory of consumer behavior, we have what? Indifference curve, according to the what? Ordinary school of thoughts. So the first thing is that the first property of an isoquant is that it is convex to its point of origin. Yes, it is convex to its point of origin. Now, on the isoquant, the slope. Now, what does the slope mean? What is a slope? Yes, what is a slope? A slope simply means the changes in the dependent variable y over the changes in the independent variable x. That is, it is a gradient that shows the rate of change in y leading to a change, the rate of change in x leading to a change in what? In y. So what is our y? Our y is our capital. Now the capital is always at the y-axis, on the y-axis, while our labor is always on the x-axis. Now, the isoquant shows a negative or an inverse effect on changes of capital to changes in what? Labor. That is, as capital falls, labor unit increases. As capital falls, labor unit increases. On the isoquant, we have the locus point. Now, each locus point of the isoquant shows that this k has fallen, what? To employ more of what? Labor. So we have something like this. We have something like this. Now, what does it mean? This is changes in labor, changes in labor, changes in labor, changes in capital, changes in capital, and changes in what? Capital. Now, you see, the rate at which capital changes as a result of what? Changes in labor in production function, we call it MRTS. What is MRTS? MRTS simply means marginal rate of technical substitution. Marginal rate of technical substitution. What is marginal rate of technical substitution? Marginal rate of technical substitution is the ratio of changes in capital to changes in labor, or is the rate at which more of labor is employed to reduce, at which more of less of capital is employed to employ more of what? Labor. So we call it marginal rate of technical substitution. And this MRCS must always be negative. Yes, it must always be what? Negative. It must always be negative. How do we express our marginal rate of technical substitution? That is MPK over MPN. Or we say changes in K over changes in N. However, if we are given, if we have it in terms of a function, we apply what we call differential calculus by saying what? The K, the N, that is changes in K over changes in N. Now you see, MPK and MPN, they are under our marginal product, because in production, we have two types of marginal products. We have marginal product of labor, which is our MPN, and we have marginal product of capital, which is our MPK. What is marginal product of labor? Marginal product of labor simply means the changes in the unit of output as a result of changes in units of what? Labor. Or when an additional output is produced by increasing our labor units. So our MPN is our what? Changes in Q over changes in N. Changes in Q over changes in N. While our MPK is changes in Q over changes in capital. That is changes in quantity over changes in what? Capital. Now, we said our MPL over our MPK. Now, let's bring it out. We say MP. What is MPL? Our MPL is the Q, the L, then divided by the Q, the K. So that means our the Q, the L multiplied by the K. This is reciprocal. So this division will change to times. While the K will come up, the Q will what? Go down. So we have the Q we what? We cancel out. So we have what? The K, the L. So that's how we arrive at what? Changes in K over changes in L. So our MRTS is the K, the L. Let me quickly show you something using our isoquant. Now, I said our isoquant is negatively sloped, which is convex to the point of origin, and it must be negative. It must be negative. It must be negative. So let's say we have 1 unit of labor, 2 units of labor, and we have 3 units of labor. This is our isoquant. This is our isoquant. Then here we have 10 units of capital, 15 units of capital, 24 units of capital. So we have our capital and we have our what? Labor. We have our 3 locus points. Our locus points, which shows the connection between the 2 axes. So here we have locus A, locus B, locus C. Now, I said at locus C, what is the MRTS? That is, what is the marginal rate of technical substitution? So I will say our MRTS equals our what? Changes in K over changes in N. So what is the changes in K? At locus C is the current unit of K. What is the unit of K? 10 minus what? What is the previous one? Minus 15 over what is the unit of labor at C? 3 minus what? What is the at B? That's 2. So it simply means 10 minus 15, which is minus 5 over 1, and that is what? Minus 5. So our LRTS at point K on the isoquant is what? Minus 5. So that's why I said the marginal rate of technical substitution must always be negative. Why? Because it shows the negative effect on capital while employing more units of what? Labor. But one thing we must note is that at A, if the producer is producing 20 units, it simply means at B is also producing 20 units, at C also produces 20 units, because the slope of the isoquant represents equal production or equal quantity. That's why we call it isoquant, equal quantity produced at different levels of labor and capital. However, on our graph, when we have two or more isoquants, the isoquant map, it simply means each isoquant shows different level of output. Now we can relate this to indifference curve. If here you produce 20 units, here you are producing 30 units, here you are producing 40 units. When you have two or more isoquants, production output level, they are not the same. But on a particular isoquant, on each locus, production is the same thing, but it shows the marginal rate. The slope of an isoquant is called marginal rate of technical substitution. The slope of an isoquant is called what? Marginal rate of technical substitution, which shows the ratio of NPK to NPN. Now, one thing is the isoquant must not touch. When we have more than one isoquant, it must not what? Touch. And the further the isoquant is to the point of origin, the higher the output. The closer, when there is more proximity of the isoquant and the point of origin, the lesser the output. That is why the closest isoquant to this point of origin is showing the least output. But on one isoquant, output is the same. But on the locus of that same isoquant, the production input of labor and capital are at different levels. So we have talked about isoquant. Now let's look at isocost. Alright, so let us quickly talk about our isocost. From the word isocost, isocost simply means the money spent on the combination of labor and capital to produce a given level of output. So we call it the budget constraints. The budget constraints in our production function is represented by our isocost. So equal cost, equal cost. Now our isocost is expressed as N equals PLL, then plus PKK. Now, how do I mean? M here is our isocost. So it is our constraint. It is the budget, money spent, the income of a producer to be spent on price of labor and capital. Now, why do we multiply price of labor to labor? This L represents quantity of labor, quantity of capital. Why do we multiply price of labor to labor? Because we can use more than one labor, we can use more than one capital. So the price of each labor multiplied by the total quantity of labor will give us the total amount spent on labor, and also will give us the total amount spent on capital. So the expression of our isoquant is N, or in some cases you will see Y. It's our budget. What is budget? Budget shows relationship between income and expenditure. This is our expenditure, showing our cost. This is our budget, showing our income. So the income of the producer to be spent on, the amount to be spent on the increment of capital and labor at their respective prices, it what shows our isocost. And our isocost curve is represented using a straight linear curve. When we have something like this, it is our isocost. So here we have K over price of K. Here we have N over what? Price of N. So it simply means when it touches the y-axis and the x-axis, there is an intercept. What is an intercept? Intercept is a constant, and it occurs when the regression line touches only of the x-axis or the y-axis. So at this point, it simply means all your money is spent on capital, 0 units of what? labor, and at this point all your money is spent on labor and 0 unit of what? Capital. So this and this, they are not visible. Why? Because it has to do with combination of both. It's not possible to produce without labor and employing only capital. Same thing is not possible to produce without capital and employing only labor. So our ISO quant start after our ISO quant start immediately after the two intercept. So at this point, these are what shows the ratio. So the slope of the ISO cost. Remember I said slope of an ISO quant is the MRTS. Are you getting it now? Which shows the rate at which one is substituted for the other. But the slope of the ISO cost shows the ratio of the two prices of the inputs. So what is that? That is price of K over price of what? L. The ISO cost shows the ratio of the prices of the two inputs, which is the price of capital over price of labor. So the ratio of the two prices is also negative, because the slope is a negative what? Slope. So this is our ISO cost. Don't forget our ISO cost, it shows the money, total amount of money to be spent on the combination of labor and capital at their respective what? Prices, which is denoted by either M or Y. So that's our ISO. Now let us now connect our ISO quant and our ISO cost together. Now how do we connect that? This is how we connect, because what we want to achieve here is what we call producer's equilibrium, or we call it producer's optimality. And what is producer's optimality? Producer's optimality occurs when the ISO quant is tangential to the ISO cost. When the ISO quant is tangential to the ISO cost. When the ISO quant is tangential to the ISO cost. So remember that this our ISO quant. This is our ISO quant. But there's a mistake I made here. I'm supposed to draw our ISO cost first. So let me just put it here. So we have our ISO cost. So this is our ISO cost. This is our what? ISO quant. Now you see, we can. Remember I told you that we can have more than one ISO quant, and each ISO quant simply means different units of output. So let's say we have ISO quant 1, ISO quant 2, and ISO quant 3. Between these three ISO quant, which one shows the point of a producer's optimality? It is our ISO quant 2. Why? Because it is the ISO quant that is tangential to the ISO cost. So we call it point of tangency. If we don't call it point of tangency, we can call it point of producer's equilibrium, or we call it the optimality point of a producer. Optimality point of a producer. Now, you see, any ISO quant that extend beyond the ISO cost, it simply means that production at this point is not feasible. Why is it not feasible? Because we can only produce within our limited resources. So that is why we call this a constraint. This constraint, it what shows the limit of our ISO quant. You cannot produce beyond a curve that extend above our ISO cost. So the one below, it simply means the production is still very limited compared to what we can still produce. So we have to increase our production to a point where the ISO cost is tangential, the ISO quant is tangential to the ISO cost. So at this point, we now say, what is the slope? That means the slope of the ISO cost and ISO quant, they are what? Equal. So what is the slope of the ISO cost? We say minus PK over what? PN. And what is the slope of our ISO quant, which is the MRTS? That is what? Minus MPK over MPN. So independently, PK over PN is always negative. MPK over MPN is always negative. So if we have this equation, we can say minus cancel minus. So at equilibrium, PK over PN equals MPK over MPN. So this is the equilibrium condition we normally use when we want to do our further calculation to derive units of labor and units of what? Capital. that can produce a particular output. So this is the equilibrium condition. So most times we use this condition for our further calculation of for deriving units of labor, units of capital when we are given a production function. So oftentimes they will give us the Cobb-Douglas production function. If you don't want to use this, we can also use another function in economics. We call it the Lagrangian function. The Lagrangian function. That is another aspect entirely. So we are still going to get the same result. So we use Pk over Pn equals Npk over. This is to show the equilibrium position. So the highest output that can be produced is gotten using this condition. Now let me go back to our Cobb-Douglas function, which says Q equals AK alpha L beta. Now what is AK alpha L beta? I told you that A is our technical progress, K is our capital, L is our labor. This is the proportion of capital and proportion of what? Labor. Q is our what? Quantity. So imagine we have the production function and they say we should derive our NPK and our NPN. Now from here, how can we derive our NPK and our NPN? It's very simple. Our NPK is what? The K over what? The N. So we are using differential calculus. Why? Because it is form of a function. So we have the K over what? The N. Now, we are going to use what we call partial differentiation. And when do we use partial differentiation? When we have more than one independent what? Variable. So the one that relates to the capital, we are going to use, we'll be using capital. So this is the Q over the K. Sorry for that. This is the Q over what? The K. That's changes in quantity over changes in capital. So using partial differentiation, the differentiation sign is going to change. So you have something like the Q over the K equals, now how do you differentiate this? Now we are dealing with K, abi? So what is the power of K? The index of K is what? Alpha. So alpha multiplied with the coefficient of K, which will be what? Alpha A, K, then raised power alpha minus 1 L beta. So that's our NPK. Then to get our NPN, which is the Q, the L, will now be, what's the index? Beta. So beta multiply A, that's we have beta A, K alpha, then L beta minus 1. So what am I trying to say? Here is our NPK and here is our NPN. So NPK over NPN, which is this over this, then the price of both. So we use this to get our units of labor and capital. But we already know the value for our what? Quantity. Yes, because they will give us, they will express it in form of an equation. So when we solve for that, we are going to use indices. Yes, we use indices to get our answer. So before that, you first of all make one subject of the formula. And you know, as you go on, you get your value for either capital first, then from the one that you have used as subject of formula, you get your labor, and other questions that will be asked, you can also derive it using this function. So that's how we go about this. So I believe that is all on production function. But in case you have anything to add to this, you can let us know in our comment section. Thank you very much.